In question 12, we have to know about symmetry. The rotational symmetry is what we have been asked. Now, here it's just not that we need to write the center of symmetry, the state, the order, magnitude of symmetry, and also identify whether it's point symmetry. I'll tell you what's point symmetry. Point symmetry is very simple. If at all, you can rotate something by 180 degree and map onto itself. Now, if you have, say, a rectangle, if I do 90 degrees, what's going to happen? It's going to be like this, right? But if I do 180 degrees, it's going to map onto itself. So point of 180 degree, if it happens, it's point symmetry. Now, are these point symmetry? How we can do is just map them inverted. This is like a shortcut thing. Like if you map them inverted, is it the same? No, there is no point symmetry over here. What about this? If you map them 180 degree, it will be like this, right? This will go up. No, it's wrong. So there is no point symmetry over here. Only shapes like this, or parallelograms you will have. Proper parallelograms, you can have point symmetry. Now then, what does rotational symmetry mean? Say any object, if you rotate it by 360 degrees, it will map onto itself. Maybe a weird shape. Okay, this is a very weird shape. But if you do 360 degrees, this point comes back over here, original, everything comes back to its original positions, right? So yes, obviously they will map onto itself for 360 degrees. But can it be done before that? If it is done before that, then it has rotational symmetry. For all regular pentagon, this is a pentagon, right? Yeah, it's 5 sides. Regular shapes, regular hexagon and all, it's easier. There is a simple formula to understand. But otherwise, you need to analyze it. See this object. It's not regular. All sides are not same. So if I move by 90 degree, let me take this as A, B, C, D. I move by over here. This shape comes. All the sides are changed to another sides. So what happens is this D goes up like this. C is over here. B will become over here, and this is A. So now A, B, C, D. Is it mapping onto itself? Is it the same thing? No. Now let me do it again. Let me change all this. Over here, what happens is A goes like this, B is something like this, small C and D. Again, not the same. If this is 90, 180, let me do it again. Now this inverted side is down, still not same. But if I do it again, then it comes back to its original position. So it will take me 360 degrees. So there is no rotational symmetry over here because in 360 degrees, everything maps onto itself. But now what about this one? Now let me take this as, say, A, B, C, D, and E. Let me do one side at a time. Now over here I took 90 degrees. Why? Because there are 4 sides, right? So the easier way to understand is 360 degree divided by its sides. 4, it will be 90 degrees, right? And we will try for 90 degrees. That's how we simply start. Now over here, if you want to know how many degrees, it is basically 360 degrees by 5. So it'll be 7 times is 350, 7 plus 2 is 72 degrees. So 72 degrees, if you do, it should shape onto itself. If it is not, then it doesn't have. Then you need to do one more, and so on. It is not a guarantee that this is the answer. But since this is regular, yes. But if it's not the same shape, it doesn't work like this, okay? So now over here, what we have to do, let me get those back. Let me just change the angle by 72 degrees. So what happens is this B, right, moves over here, and that E goes over here, A over here, C over here, and this. So now here it's A, B, C, D, E, and it is mapping onto itself. Now this is not accurate, but if you draw it accurately, it maps onto itself. That means it has rotational symmetry before 360 degrees. You don't have to wait 360, right? We already got it. Now, if it is all regular sides, regular means equal sides, this is it. This is the angle of rotational symmetry. But what is the magnitude? Magnitude is basically the sides, how many sides it has. 5, right? That will be the magnitude because you can keep on changing it 5 times before 360 degree. Now this is C, right? I'll move this again. Now this will be B. Then it will be A. Then it will be E. Sorry, it will be, yeah, E. And then it will be lastly D. D was the original. So how many magnitude is there? From To get back to D, it is 1, 2, 3, 4, 5 times. So that is basically magnitude. How many times we can rotate it to map itself. So rotational symmetry exists over here. Yes. Order is phi, that is order. Magnitude is the degree. Sorry, I was saying order. How many times you can rotate it within 360 degrees? 5 times. The magnitude is 360 by 5. That's for 72 degrees. Here, nothing. It's all no or none or none. But does this have point symmetry? I told you point symmetry is 180-degree rotation. No, both doesn't have point symmetry. Now, what about this shape here? Both are parallel. It's a parallelogram, parallel sides. Now, let's rotate it by, say, 360 by 4 sides, 90 degrees. Let's try rotating at 90 degree. If I rotate it, it's going to be, this is small side. This is big, big, small. It's not the same. They are different. But let me rotate it again. Then this is going to be small, big, big, small. Now it will map onto itself. So it will take 180 degrees to rotate, right? So if it is taking 180 degrees to rotate, that is the magnitude. The order will be 2. 2 times it can be rotated. Yes, it has rotational symmetry. Order is 2. Magnitude is 180 degrees. And now this has point symmetry. Why? Because it can be rotated 180 degree about its center. If you rotate it by 180 degree, you can get to itself. Let us look into a check problem as well. You can try this by yourself. Please do it by yourselves and then check the answers. Here, yes, there is rotational symmetry, you can say for sure. But now, since the shapes and sides are not same, the order will be 2 and it's 180 degree, just like the previous problem. What about this? No, there is no way you can get it onto itself. There is no order, none magnitude. Now here, since all the sides of this triangle are same, it's an equilateral triangle, the order will be 3 sides. And magnitude will be 360 by 3, it's 60 degrees. And yes, rotational symmetry exists. 360 by 3 is 120 degrees. Now, which of this has point symmetry? Now, if you rotate all these, you will never, at 180 degree, you will not get it back. So it will be something like this. No, it's not possible. Only this is possible if it's rectangular or parallelogram. The rectangle has point symmetry because it can be rotated 180 degree about its center and it maps onto itself. So that's the end of question 12.